Hi everyone. This is the second part of example 10 from chapter 12 in the student packet. So we have the same scenario here. We have a shelter that has 24 dogs, 18 cats. 8 of the dogs are male and 6 of the cats are male. It says, suppose an animal from this shelter is chosen at random, and if you choose to randomly adopt 2 pets, what is the probability that both are cats? So this is a review of the idea of without replacement, because we have a discrete number of animals here, and if you choose one cat, you're not putting it back before you choose the second cat, right? You're keeping that first cat and therefore changing the total number of animals and the total number of cats that are then available for you to choose for the second animal. So what's the probability that both are cats? So the probability that the first animal is a cat, well, again, we have 18 cats, and if you remember from the other part, we had a total of 42 animals. So that's the probability that we choose the first cat. Then we chose a cat, which means that the number of animals is reduced by 1, and the number of cats is reduced by 1. And therefore, the probability of choosing a second cat is 17 out of 41. And when we multiply these together, we get 0.178. For part F, it says, what's the probability of choosing exactly one cat? Well, there's 2 ways that we can choose one cat. We can first choose a cat and then choose a dog. Or we can first choose a dog and then choose a cat. Those are the 2 scenarios for choosing exactly one cat. So that means that we are looking at the probability of choosing a dog and then a cat, or the probability of choosing a cat and then a dog. Well, the probability of choosing a dog is 24 out of 42. We chose a dog, therefore the total number of animals left to choose from is reduced to 41. But we didn't choose a cat, so we have the same number of cats left over, and that gives us 18 out of 41. Or the other scenario is that we choose a cat first. So we choose a cat out of the total 42 animals. But we've now chosen an animal, so we're down to 41 animals left, and we're choosing a dog. So notice we got the same value both times, but you can just put this in your calculator, and you're going to get 0.5. And I was going to go into a whole explanation of why this makes sense, but I'm going to move on. Okay, so let's see, for part G, we're looking at the probability of at least one cat. And remember that you're choosing 2 pets. So we talked about the at least one idea before. And the probability of at least one cat means the probability of choosing 1 or 2 cats. And the complement of that is that we don't choose any cats. And that is the equivalent of choosing 2 dogs. So that's the same as the probability of choosing a dog and then another dog. So choosing a dog, we have 24 out of the 42 animals are dogs. And then we're going to look at the probability of choosing a second dog. So the number of animals is reduced to 41, and the number of dogs is now reduced to 23. And don't forget that we're doing 1 minus this value, giving us 0.679.